Yes, so here we are talking about reactions of alkenes. So here, the first reaction that we are talking about is between the reaction of alkenes with bromine liquid, keeping in mind that this reaction is used to test for unsaturated compounds. So basically, this is the test to distinguish between, this is the test for saturated or unsaturated, to distinguish between, test for distinguishing between what? Between saturated and unsaturated compounds. Okay, so here we will see that how alkenes, they react with bromine water. This is also called test for bromine water. What will happen? You are going to take an alkene when we are talking about, let's say if I am going to take ethene. Okay, so ethene will react with bromine. Ethene reacts with bromine. And what will be formed when I am talking about, I am going to make 1,2-dibromoethane. See how I am going to draw so you understand. Okay, so ethene, what is the formula of ethene? I already know that this is C2H4. C2H4. Plus I have what? I have bromine, Br2. Halogens always exist as diatomic form. Then, I am going to draw the structural formula of it. When I draw carbon-carbon double bond, H, right? This is my ethene. And it is going to react with bromine. Now, 1,2-dibromoethane, how it is going to be formed? 1, 2 means 1, 2 will have bromine. Here, ethane. Yeah. So this is going to be our 1,2-dibromoethane. And when, we are talking about it, that, how this reaction happens, what is the observation? As I said, that this is the test to distinguish between saturated and unsaturated compounds. So what will be the observation when I am talking about? Yeah, that is also important. I think so. I write here observation. So observation with alkane, what will happen with alkane? It stays orange. Okay, and with alkene, what will happen? It decolorizes. What decolorizes? Bromine, right? So this is what, we have to remember, that this is the test to distinguish between alkanes and alkenes. Bromine water test, which will stay, okay, saturated and unsaturated compounds. So saturated compounds, what? Alkane. Okay, when we are talking about alkenes, unsaturated, they will what? They will decolorize. So this is also called the test for bromine. Okay, so this is one of the reaction that we have discussed about alkenes. Keeping in mind, this is also called addition reaction. Addition reaction, as we see in addition reaction, two reactants, they react and only one product is formed. Now let's talk about one more addition reaction of it, where what will happen? It is going to be the reaction of alkenes with hydrogen. Reactions of alkenes with hydrogen. We also call it hydrogenation, since it involves hydrogen. So we also call it hydrogenation. Okay, now what is gonna happen in it? Let's see how it works. Let's write the word equation first. So when ethene, it is reacting with ethene, reacting with hydrogen, forming what? Forming ethane. Okay, and we can write the equation for that. Ethene, we know C2H4 plus hydrogen. It is going to give us ethane, C2H6. Let's draw the structure as well. C2H4 ethene, so it will have double bond, keeping in mind. Then what we will have hydrogen. Gases always exist diatomic form. Then we will have ethane. C2H6, and this is going to be our equation. Other than that, there will be reaction conditions as well that we need to remember for this. What are the reaction conditions? That certain temperature is required. What temperature? About 60 degrees Celsius. So here, what we will put the heading for reaction conditions. Reaction conditions for hydrogenation. So what you would need the temperature, which is about 60 degrees Celsius, and also you would need catalyst. What is the catalyst that you will be using? It is liquid. Yeah, so these are the reaction conditions that you would need for hydrogenation reaction, which is also the example of addition reaction. As we can see that two reactants react and only one product is formed. Now we will talk about more reactions of alkenes. Okay, so here, let me take up. Okay. Okay, so here more chemical reactions of alkenes when we are talking about. So here, reaction of alkenes with what we will talk about steam, where it reacts with alkenes to form alcohols. Steam reacts with alkenes to form alcohol. Okay, so now how it is going to be, let's write the word equation first, where you will have ethene reacting with steam, and it is going to give you alcohol. Which alcohol? Ethene reacting, so ethanol. Let's write the structural equation of it. Yeah, and here also, in this reaction, we have the reaction conditions that we need to remember. So ethene, C2H4. Then we have steam, so H2O. And we have ethanol, C2H5OH, right? So this is going to be our equation for ethene reacting with steam to form ethanol. Now here also we will have the reaction conditions. And as I always say, do write the formula equations. So C2H4 plus H2O and it is giving you what? C2H5OH. Keeping in mind, there will also be the reaction conditions that we will consider. So let me write it here. Reaction conditions that we would require. So reaction conditions, what are we talking about? We will talk about high temperature, high pressure, high temperature. Oops, it is not very high temperature, about 300 degrees Celsius. Then we will talk about high pressure. Okay, about 6,000 K Pascal. Okay, and then we will have catalyst as well, which is concentrated phosphoric acid. This is important to mention because sometimes in the exam, 1 mark for concentrated and 1 mark for phosphoric acid. So concentrated phosphoric acid, let me write it here. Concentrated phosphoric acid. What is the formula? H3PL. So these are going to be our reaction conditions for this reaction. Reaction of alkenes with steam to form alcohol. So yeah, one more reaction of alkenes, ethene, which reacts with oxygen. So ethene is what? C2H4. Reacts with oxygen, O2, forms carbon dioxide, CO2, plus water, H2O. Let's balance the equation. Yeah, this is balanced, right? Keeping in mind, this is the same reaction that we did for alkenes as well. Complete combustion, where enough oxygen is present to react with, in this case, alkenes. It reacts with alkenes also. And what will be formed in complete combustion? The products will always be carbon dioxide. And in incomplete combustion, the products are going to be carbon monoxide and water. So this is the difference between complete and incomplete combustion as well.